Hi, I am Jagdish, Assistant Professor of EC Department, SNS College of Technology, Coimbatore. Today, we are going to discuss about the pulse modulation. Already, we are discussing so many topics in the previous episodes in the under the communication systems video lecture series. So here we are going to discuss about the pulse modulation. So come, let's dive into the topic. So what is actually a pulse modulation? The process of transmitting signal in the form of pulses, that is a discontinuous signals by using special techniques. So the special techniques are pulse amplitude modulation called as PAM, then pulse width modulation PWM, and pulse position modulation PPM, and pulse code modulation PCM. So these are all the different methods. So first one, what is pulse modulation? So pulse modulation is nothing but it has analog pulse modulation and digital pulse modulation. So pulse amplitude modulation, which comes under the analog pulse modulation, and pulse width modulation (PWM), and pulse position modulation. And when you are coming for the digital pulse modulation, we have a pulse code modulation, then delta modulation, the DM. And when you are coming for the pulse amplitude modulation block diagram representation, input signal we are giving analog one, and AND gate will be there. AND gate which has the input, another input, that is a pulses at sampling frequency. So finally, at the output of AND gate, we will have a pulse amplitude modulation in some certain time period. We will have some output, right? That output will be given to the pulse shaping network. So here the pulse, the exact pulses, right? The for 1 and 0 for the interval, the pulse shaping will take place, right? And then after that, that will be given to the FM modulator, that is a frequency modulation. And we have a PAM FM output will be there. And for the FM modulator, we already know the modulator which needs the high frequency carrier signal. So here HF carrier oscillator which generates the high frequency signals to the FM modulator. So this is the simple block diagram of pulse amplitude modulation. Here you could see the output, the graphical representation. The input I said was an analog signal, where the pulse amplitude modulation which undulate, which will be given to the which will be multiplied with the original signal. So we have a pulses, right? So pulse, this is called a pulse modulation. So the peak points, right, the edges will be called as a 1, and the straight line will be considered as a 0, right? So 1 means we have some value, and 0 means there is no value, no information like that we will be considering. So by using the analog signal and the pulse sampling frequency, we will get a pulse output. This is called a pulse amplitude modulation, pulse modulation. So pulse width modulation. Here, pulse width modulation is according to the input signal. Let's say if the analog signal information, that is say amplitude increases, the width of the pulse will be increases. When it decreases, when it goes down, that is 0 and below 0, then automatically the width of the pulse will be reduced. So that's why it is called a pulse width modulation. Next, pulse position modulation. So here, pulse width modulation already discussed. Pulse position means according to the information signal, this analog signal, the position of the pulses will be changed. That is called a pulse position modulation. So let us compare PAM, PPM, and PWM in a single graph. So first input is analog signal, that is commonly we are taken. So the remaining thing, amplitude modulated pulse, width modulated pulse, and position modulation pulse is equivalently, that has been shown in this diagram for clear cut understanding between these three methods. Okay, hope you have understood the pulse amplitude modulation and width modulation and position modulation. So the conclusion is PAM, PPM, and PWM are fundamental analog and digital modulation technique used primarily in the communication and control systems. Each has its unique method for encoding information. So encoding information in the sense, so we have analog signal. So for encoding is nothing but the analog signal will be converted into a zeros and ones. That is called encoding. So PAM is easy to implement but less noise resistant, and PPM provides better noise performance but it's complex due to timing requirements. PWM is ideal for power control and digital signal application due to its robustness and efficiency. And let us have the assessment. So these are all the questions. In PAM, the information is encoded in the form of dash, and which modulation technique is more susceptible to noise. So just like that, giving answer is not enough. You have to give the proper justification for your answer. You kindly discuss with your teammates and give your answers. Thank you.